Okay, finally the FRQ. F is a differentiable function whose continuous derivative f prime is shown right here. So this is continuous. The graph consists of 2 quarter circles and 1 line segment, as we can see here. Okay, part A. Find the x-coordinate of each point at which the graph of f has a horizontal tangent line on this interval. All right, so if f has a horizontal tangent line, that means that f prime is equal to 0. All right, so when is f prime equal to 0? Right there and right there. Okay, so we need the x-coordinates. So the x-coordinate here is -3. The x-coordinate there, it looks like it's right in between 1 and 2. So it looks like it's 3/2, 1.5. You should probably double check that. We can see that we're going down 1 and over 2, down 2 and over 1, down 2 and over 1, down 2 and over 1. Our slope is -2, so that does verify that we have that right there is x equals 1/2. All right, so x is equal to -3 and x is equal to 1/2. Okay, for each of these points, determine whether f has a relative min, a relative max, or neither, and justify your answers. Okay, well, what's going on at -4? The derivative is negative and then positive. If the derivative is negative and changes to positive, that is a relative minimum. All right, so at x equals -3, f has a relative min. Right, because f prime changes from negative to positive. Right. And then the reverse is true over here. F prime was positive and then changes to negative. So at x equals 1/2, f has a relative max. Right, because f prime changes from positive to negative. Part B, find all values of x on this interval for which the graph of f has a point of inflection. And once again, we have to give a reason why. Okay, inflection points occur when the first derivative changes from increasing to decreasing or decreasing to increasing. So let's go back up here. Our first derivative is increasing. And at this point, it begins to decrease. And it decreases the rest of the way. So this is our only point of inflection when x is 0. All right. So x equals 0 because f prime changes from increasing to decreasing. And last but not least, find the average rate of change of f prime on the interval from -4 to 3. Okay, let's do that first. Average rate of change. Let's go back up and take a look at the graph. Here are our points. Right, so we've got our y-coordinates are -1 and -3. Our x-coordinates are -4 and 3. We're trying to find the slope of that line right there. We know the answer will be negative. Okay, so let's do the math. All right. y1 minus y2 over x1 minus x2. This is good enough for the point. We are going to have to talk more about the mean value theorem, but you don't have to actually go any further than this. If you do go further, that's fine. Just be careful. -1 minus -3, so that's -1 plus 3, so that's going to be a 2. And then -4 minus 3 is -7. So yeah, so -2/7 is the average rate of change. But again, this is good enough. Right? We then see there is no point C for which f double prime of C is equal to this value. Explain why this statement does not contradict the mean value theorem. Okay, so why doesn't this work? Right, think about the conditions of the mean value theorem. Function has to be continuous, and it is. Right, but it also has to be differentiable on the open interval. And we have not one, but 2 points where f prime is not differentiable. And when 2 quarter circles meet, that is a temporarily, just for a moment, it goes vertical. So there's 2 spots there. All right? But we don't even have to mention the spots. You can. Ultimately, you have to state, you can explain why a statement does not contradict the mean value theorem. So the MVT requires differentiability on the open interval. Notice I'm not including the endpoints. Right? And f prime is not differentiable on this interval. Or if you want to just say, do the easy one, do the cusp at x equals 0. Or again, you could have used -3 here, because that would work as well. Okay. I should actually, the mean value theorem requires differentiability for f prime. All right, we should mention that we need f prime to be differentiable, and f prime is not differentiable at that point. Okay, so hopefully this helps. We'll see you soon.